What causes common mode noise in analog signal processing? Imagine you are trying to listen to a clear radio station, but suddenly you hear a hissing sound that affects both your headphones equally. That's similar to what happens with common mode noise in analog signal processing. It sneaks into your system from outside sources and affects multiple lines at once, making it hard to tell the real signal from the noise. Common mode noise mainly comes from interference that appears on two or more signal lines relative to a shared reference point, usually ground. Think of it like two friends walking side by side, both getting pushed by the same gust of wind. This interference can come from several sources. One big cause is capacitive and inductive coupling from external sources like nearby power lines, radio transmitters, or switching power supplies. These sources generate electric and magnetic fields that induce unwanted currents equally on both signal lines. Another cause is differences in ground potential. If different parts of a system have ground points at slightly different voltages, it creates a voltage difference. This difference causes currents to flow through the ground connections, which then appear as common mode noise. It's like two houses sharing a ground wire that's slightly higher in one house than the other, causing a small but continuous voltage difference. Imbalances in the transmission paths also contribute. If one signal line is longer or has different electrical properties than the other, the signals can become skewed. This imbalance turns what should be a differential signal into a common mode signal, adding noise. PCB layout issues, such as gaps in ground planes or uneven routing, can also cause parts of the signal to convert into noise. Stray capacitances between signal lines and ground planes can pick up electromagnetic interference. Electromagnetic interference from nearby circuits, especially digital or switching power electronics, can induce high-frequency noise. This noise couples into analog lines through stray capacitances and mutual inductance, creating common mode currents. Lastly, if the signal drivers are imbalanced or operate from single-ended power supplies, they can introduce DC offsets or imbalances, which show up as common mode voltages. All these factors combine to produce common mode noise that can distort signals, cause errors, or even interfere with electromagnetic compatibility. To reduce this noise, engineers use techniques like careful PCB layout to keep lines symmetrical, twisted pair or shielded cables to cancel out interference, proper grounding to avoid ground loops, and differential amplifiers with high common mode rejection ratios. Understanding what causes common mode noise helps in designing systems that keep signals clean and accurate. It's about controlling the environment and the layout so that unwanted interference doesn't get a chance to affect your signals.